Hello again. Welcome to Mr. Jackson's chemistry class. Today I would like to talk about temperature. Remember, I have notes here on my left side and I have a PowerPoint here on the right side. You can stop the video anytime and do a screenshot if you're taking notes. No problem. But I'm going to go on through and let's talk about temperature. What is temperature? Temperature, we have to understand, is not something you can sense with your hand. Temperature actually has a number measurement, and people are always confused when they think about their hands. I know you can feel things that are hot or cold, but you cannot tell temperature. Temperature is an exact measurement of hot and cold. And how do we do that? Well, let me talk about our hands for a minute. If I have my hand can only tell me if I get near something that has more energy than my hand or less. If I touch something that has more energy, like let's say, a hot pot on the stove, energy enters into my hand and it feels hot or warm. Okay, but if I go out in the snow and make a snowball with my bare hands, that snowball feels very cold. That's because energy leaves my hand. So your hands can only tell you if energy is flowing out or if energy is flowing in. So that's why you see my little pictures of hands up here with an E, and E stands for energy, which we just talked about in the last set of notes. So when you touch something that feels cold, like a piece of metal, that means energy is leaving your hand and you have the sensation of cold. So cold is when energy leaves the human body. Okay? And if something is hot or warm, let's say you stand in front of a heat lamp and you feel warm, that's because energy is entering your body or entering your hand and your skin. So your body can only tell you if energy is going in or out. It can't actually tell you what the temperature is, because when you touch something, you just either know if energy is moving into your hand or out. So let's really define more logically what is temperature. Temperature is the measure of the average kinetic energy of the system. So it's a measurement of the motion of the system. Remember, we talked about kinetic energy being things that are in motion. So it's the motion of the speed of the particles. So when we're measuring the temperature of something, we're just measuring how fast the particles are moving around. And our hands cannot tell us the temperature. It can only tell us if our hands are touching something warmer or colder. So if I'm sick and I touch somebody's head and they feel cold, then I would think that, they're fine, they feel good. But the problem is I have the temperature, so I'm warmer than them. So energy would flow out because they're colder than me, and so I would think that they're cooler. But the truth is I could be sick. So my hands can't tell temperature. So let's talk about how does a thermometer work. So this may clarify what I'm talking about here with kinetic energy. Whenever you have something that's warm, that means there are particles. Let's just take this water. Let's make this water warm. This water is made up of a whole bunch of particles, okay, called molecules. And these molecules are moving around, and they're actually bumping off the side of the thermometer. They're even bumping off the sides of the beaker and off the bottom. But as they collide into the thermometer, they begin to make the thermometer vibrate, kind of like when you put a coffee cup on your dashboard of your car and you start your car. The car begins to vibrate, and so then the coffee vibrates because the vibrations of the car transfer to the cup. So the vibrations in warm water begin to transfer to the thermometer and makes the thermometer vibrate, and that makes the material need more room, so it expands up the tube. And so as the water rises, it means it's encountering more vibrations. So warm water means more kinetic energy, which means more vibrations. Okay? And so what a thermometer is doing is it's matching the motion of the material. But if you take some material, let's just take this water and we cool it down, there are still particles. We haven't gotten rid of the particles. They're still in there. But what's happened is those particles have slowed down. So now instead of hitting the thermometer a whole bunch of times, it's striking it less times and not as strongly, and it's striking some of the container too. But since there's less vibration, there's less collisions into the thermometer, so the thermometer doesn't vibrate as fast, and so the liquid only goes up a little ways and needing more room. So every time you put a thermometer into a material, it actually undergoes a vibration with the material. So in essence, a thermometer is a vibration checker. So anything that has a temperature has vibrations. So the truth is, if I took a solid material, so this is a solid, and let's say I drilled it, okay, and as I drill it, I put a thermometer inside, and so here's the solid, I put a hole in it, I put a thermometer in there, and if that thermometer actually got a measurement to go up, then that means that those are particles inside that solid are literally moving. And so that means that there is actually vibrations in a solid. Even though I can't feel it moving, if I get a temperature reading, then that means there's motion in that solid. Okay? So that's kind of cool. Thermometers are vibration checkers. Okay? That's the best way to explain it. That's why it's based on they measure the kinetic energy or the motion in a material. Okay? Let's move on. Let's talk about the different kinds of temperature scales. Okay? Oh, so here goes. Here's my measure my temperature. I didn't turn my slides there. Hotter particles. Thermometer just matches the particles of vibration through contact. Okay? So what is temperature? They actually are two kinds of temperature scales. They are Celsius and Kelvin. Okay? The Celsius is based on water. It's based on the boiling points and melting points of water. And so what it does is it actually just helps us figure out what are the 100 degrees between the two. So Celsius has a 0 point at the freezing point of water. So 0 is freezing, and 100 on a Celsius scale is the boiling of water. Okay? And so that's what Celsius scale was created for. It was created to match water. Okay? But Kelvin is based on energy in the system, or just you can say on energy. And what that means is if you have little energy or low energy, you have low numbers like 50 Kelvin. And then if it's higher numbers like 300 Kelvin, that means warmer or hotter. Okay? So it's based on energy. And Kelvin does not have a little degree symbol, but I sometimes add it just so people don't get confused because you're not used to seeing it. So I will add that in, but it is not the correct way of writing things. So if I wrote down, 100 Kelvin, it would actually look like that. But you're used to seeing the little degree symbol, and I usually add that just so you guys feel more comfortable. So Celsius is based on the water temperatures. Kelvin is based on energy, but it's just the same size in a sense as a Celsius. Boiling of water is 273 degrees Kelvin. Boiling of water is 373. So the same thing for freezing and boiling is 100 degrees apart on the Kelvin scale. Okay? So, but we have a special thing. We'll talk about it here in a minute. Well, how do we change between Kelvin and Celsius? It's pretty simple. They're right here. So just remember that Kelvin has higher numbers. So to go from a smaller number, C, if you think about it this way, if you have a little stair step, okay, you have C down here, then K would be higher up. And so you want to go higher, you would have to add, and the magical number is 273. So if you want to turn 0 degrees Celsius into Kelvin, you would take 0 plus 273 is 273. If I had 10 degrees Celsius and I want to turn it to Kelvin, it would be 10 plus 273, so 283. Okay? So you add to go up to Kelvins. And then the reverse is true. To go to Celsius, you would subtract because you're going down in temperature. So you would be going down, so you would subtract 273. So if I had, 300 Kelvin, and I want to go back to Celsius, I'd just say 300 minus 273 would be 27. Okay? So 27 degrees Celsius. So that's how I would tell. Okay? So they're pretty easy to change between. You just got to remember the number 273, and either you're adding it to get to the higher numbers in Kelvin or you're subtracting it to get to the lower numbers in Celsius. Okay? Well, with Kelvin being a energy type system or measurement system, it helps us out with this little thing here mentioned as absolute zero here on my slide. So let's go back here and it says absolute zero. What is absolute zero? It cannot be measured. And the reason why it cannot be measured, it is a place where everything stops moving, even electrons. So even if you had an electronic thermometer, if you put it in a place that was at absolute zero, your thermometer would shut off. So this is kind of a really strange statement, but because we can't reach absolute zero, that means it really exists. If our machines shut off, then they must be approaching absolute zero, which means it's there. If we could have a machine running at absolute zero, that means there's something colder. So the lowest amount of energy we know is called absolute zero. It is the temperature at which no motion in matter exists. Everything stops moving. So there is absolutely no energy. Energy is completely gone. Even electrons stop moving. Okay? So absolute zero is kind of a really cool thing. So if we have 0 degrees on the Kelvin scale, and you see how it looks like the word OK, that's the reason why I'll add a little degree symbol there. So at 0 degrees Kelvin is considered absolute zero. Okay? That would be, to get there on the Celsius scale, 0 minus 273 would be negative 273 degrees Celsius. And that would be absolute zero. Okay? But Kelvin's, the 0 degrees on the Kelvin scale, was created for this purpose to be absolute zero. So that's the reason where this scale came from the idea based on energy. Low energy has lower Kelvin numbers. Higher energy has higher Kelvin numbers. Okay? So that's what absolute zero is. So remember, I already asked you this question earlier, I think in my previous information. So when is a solid actually moving inside? Well, guess what? If I can get a temperature reading above 0 degrees Kelvin, then even though it's a solid, there must be something moving inside. So anytime you have a temperature reading and you have that reading means there is some kind of motion going on. Okay? So I wanted to bring up what was absolute zero. Okay? And that gets us through our temperature scales and how we read things. We also know that in America we have what's called as Fahrenheit scales, and we're not going to do the math with those. Chemists pretty much use Celsius and Kelvin. So if you have these two scales down, these are the two major scales we're going to use in chemistry using for the mathematics. We don't use Fahrenheit in our math. But it is a scale that was created for Americans, but we don't use it in chemistry because all of our math is based on these two scales, okay? Celsius and Kelvin. All right, so we'll talk about heat the next time we come back. Thank you very much for joining me. Have a great day.